Okay, this is geometric progression. Okay, so term number is a r raised to power n minus 1. Previously, for AP, it was Tn is equal to a plus n minus 1 into d. Just for comparison, I'm writing this. And then we had sum of terms. Sum of terms was n by 2 into 2a plus n minus 1 into d. Or we had another formula, which was n by 2 into a plus l. And for this term, we have a into 1 minus r raised to power n over 1 minus r. And now what is r? Basically, in arithmetic progression, we had common difference. In geometric progression, we have common ratio. So r is basically Tn plus 1 over Tn. Whatever is the second term divided by the first, or third by second, or fifth by fourth, any two consecutive. For example, 2, 4, 8, 16, 32. So r is, if we select any two, 16 by 8, r is 2. So the first term is basically being multiplied with r to get the next term. So if r is 2, after 32, we will get 64. After 64, we will get 128. So this is common ratio r. And then we'll have sum to infinity. Sum to infinity is a over 1 minus r, and the condition is that r needs to be less than 1 or more than minus 1. Definitely that would mean that it is in decimals. For example, let me say r is equals to 1 by 2 and the term starts from 100. So multiplying 100 with 1 by 2, I'm getting 50, then 25, then 12.5, then 6.25. So this keeps on decreasing and will approach 0, and we can say that we can find sum to infinity. So these are for geometric terms. Now geometric progression. Okay. Geometric progression sequence is given, for example, 7, 14, 28, 52, 112. As we can see that these are being doubled. So R in this case is equal to 2. The progression is given and common ratio is given. So all the progressions, select any two progressions. 16 by minus 8 is minus 2. Select any two. 16 by 24 is 2 by 3. Select any two. 4 by minus 8 is minus 1 by 2. And other than that, the symbols are same. Meaning of A is same, N is same, only R and D is different. D in arithmetic progression was common difference. R is common ratio. So A is first term, R is common ratio. So first term, second term, third term, fourth term, fifth term. As the formula states, A R raised to power n minus 1. So we keep on replacing this n. For the first term, when n is 1, 1 minus 1 is 0, R disappears. So that's the first term. Then 2 minus 1, 3 minus 1, 4 minus 1, 5 minus 1, so on. Worked example. The third term of geometric progression is 144. A third term is given. So basically a r raised to power n minus 1 when r n is 3. This is a r square. Third term is 144. So we write that and equate it with 144. And common ratio is given 3 by 2. So 3 by 2 squared, a is unknown, and that's 144. And it says find the seventh term. So before that, I need to know what a is. So this is 9 by 4 is equals to 144. A is equal to 144 into 4 by 9. Getting 64. A is equals to 64. Now we have everything. We have A, we have R. So A into R raised to power n minus 1. So seventh term, now I need to find the seventh term. So I just have to replace n with 7. 64 into 3 by 2 raised to power 7 minus 1 will be 6. and later we use calculator. So 3 divided by 2 power 6 into 64 is 729. So seventh term is 729. No major difference other than that we are not dealing with common difference, we are dealing with common ratio. Another worked example, the second and fourth term of the geometric progression are this and this. This is second term. So this is AR equals 108, and fourth term means AR cube is equals to 48. Now when we have this, we can deal it like simultaneous equations. So if I divide this equation by the first equation, that is going to give me 108, and A cancels out, R cancels out, left with R square, and 48 divided by 108. I'm using calculator, I'm getting 4 by 9. So when we do square root on both sides, R is equals to plus minus 2 by 3. Now I just have to check if there is any restriction, given that all terms are positive. So if the terms are positive, definitely R is 2 by 3. So the first term, find the first term. Now we have R. So I can use this same equation, substitute R and get A. Just making it that considering it is done. So first term's being done and common ratio. So R is already done, A done, hence write down the expression for nth term. So we just substitute AR raised to power n minus 1. Value of A is done, which is 162. R is done, which is 2 by 3 raised to power n minus 1. And that's it. Basically simple reading and simple substitution. The nth term of geometric progression is already given. Find the first term and common ratio. When I need to find the first term, I just need to put 1. So 30 into minus 1 by 2 raised to power 1. That is my first term, which is minus 15. Now that's the first term. So for this second term, I need to substitute 2. This will be minus 1 by 2 raised to power 2. That's 30 into 1 by 4. That is 7.5. Now we have first term. We have second term. So R is equal to second term divided by the first term, negative 1 by 2. So both done. First term and R, find the common ratio, done.
Why does it have to be dividing them? Why is it not subtracting them?
Subtraction is common difference.
Oh, and this is common ratio.
Yeah,
Okay.
this is common ratio. Arithmetic progression is common difference. Geometric progression is common ratio. It could be more than one, it could be less than one. Less than one means it is converging towards a zero. More than one means it is diverging, the number is becoming larger and larger. Another worked example, geometric progression is 2, 6, 18, 54, which is the first term to exceed 10, 100,000. So first we have this 6 divided by 2, R is equal to 3. We have common ratio. So in generic form, AR raised to power n. So A is already there, 2. R is already there, 3 raised to power n minus 1. Now what should be n that it should exceed 1,000, 1,000. So we just divide by 2, n minus 1, and divide by 2 on the other side, that's 500,000. And then we apply logs. So n minus 1 is greater than log of 500,000 divided by 3. And using calculator, mm, log of 500,000 to base 3, I'm getting 11.9. N minus 1 is greater than 11.9. 1 goes on the other side is greater than 12.9. So greater than 12.9, it has to be an integer. So that is 13. Okay, we just discussed this formula and we'll apply it. Try this worked example and give me just 30 seconds. Okay, sorry, there was someone at the door. Is this done? What
Yep, it
example?
is.
Okay,
And I
so
got the
this
same answer.
basically you just have to understand the formula and input the correct values, substitute the correct values. Okay, this says the second term of geometric progression is 9 less than the first term. So if the first term is a, the second term would be a minus 9. The sum of the second and the third term is 30. Given that all the terms in the progression are positive, find the first term. So we just assume that the second term is first minus 9. So second term is AR is equals to A minus 9. If we follow the formula AR raised to power n minus 1, A is the first term. Second is when we put 2 in n. So you get AR2 minus 1, which is AR. So that's the first term. This is the second term. And second term is 9 less than the first. So when you just rearrange, we get A is equals to 9 over 1 minus R. And then it says second term plus third term is equal to 30. Second term was AR, third term is AR square. Sum of those is equals to 30. Now we have two equations, 1 and 2. We can solve these two equations and get the value of R. And then substituting this into the first equation would definitely give us the value of A. Exercise. Identify whether or not the following sequence are geometric. If they are geometric, write down the common ratio. So first of all, we have to identify if they are geometric or not. So I look at the second term, second divided by first. It has to be multiplied or divided with the same number. We call it multiplication. We'll use it as fraction. So 2 by 1 is 2, 4 by 2 is 2, 6 by 4 is not 2. So this is not geometric. 4 by minus 1 is minus 4. 6 by 4, 16 by 4 is minus 4. 64 by 16 is minus 4. R is equals to minus 4. That is geometric and R is minus 4. Try C part. Is this geometric or not?
It is. Because the common ratio is 3, and it keeps being divided by 3. So 81 over the 27 would just be
Yeah.
divided by 3 for each term.
Divided by 3. So basically R is equals to 1 by 3.
Yep.
Okay. D. Now all these are 11. So I'm just looking at the numerators because when I'll divide the second with first, I'll get rid of 11s. So this is 3 by 2, that is 5 by 3, that is 8 by 5, and it's different. That is not geometric. Okay. Zero point 0.4 divided by 2 is zero point 0.2. So we can also check by multiplying all these with zero point 0.2. So first one 2 into zero point 0.2 is zero point 0.4. Again into zero point 0.2 is 0.08. Again into zero point 0.2 is 0.016, not 0.16. That is not geometric. Last one. 5 by minus 5 is minus 1. Minus 5 by 5 minus 1. 5 by minus 5 is minus 1. So ratio is minus 1. Question number 2. The first term in the geometric progression is A and the common ratio is R. Then write down the expression in terms of A and R for the ninth term and 20th term. Simple. Ninth term is AR raised to power 8. 20th term is AR raised to power 19. Is it okay if I write it directly? Because that was AR raised to power n minus 1. So ninth term is power 8
Yeah,
and
it's okay.
20th is
Yes.
19. Number 3. The third term of the geometric progression is 108 and sixth is minus 32. Question 3. Third term T3. So AR square is equal to 108 and sixth term AR5 is equal to minus 32. Now what is it? Is asking for find the common ratio and first term. So A and R. When we look at this, I'm dividing them both. AR raised to power 5 divided by AR square. On the other side, minus 32 divided by 108. We get rid of A. I'm left with R cube. And 32 divided by 108 is minus 8 by 27. Taking cube root on both sides, R is equals to minus 2 by 3. When R is done, we can use any of the equation. I'm using the first one. AR square is equals to 108. A into minus 2 by 3 squared equals 108. A times 4 by 9 is equals to 108. A equals 108 into 9 by 4. And that's 243. So A is 243 and R is equals to 2 by 3. R is equals to minus 2 by 3. Okay. The first term of geometric progression is this, and this is exercise 11.4. Try question number 4. Let me reopen the key as well. 11.4. Number 3, 11.4, question number 4. Okay. Try fourth question.
Question 4.
Yeah.
For some reason, I'm getting a decimal value. I'm getting 16.2.
Yeah, no issues.
And
You
I'm
can
only
get
getting one value, not two.
question
Oh wait,
four.
I know. It's because we square rooted, it has to be either positive or negative. So it has to be positive 3/5 or negative 3/5, I guess.
That is correct.
Okay.
16.2 is
Okay.
correct. Number 5. The second term of geometric progression is 12. Question 5. T2, that is AR is equals to 12. And the fourth term, so T4 is equals to AR cube is equals to 27. Given that all the terms are positive, find the common ratio at first term, R and A, and the terms are positive. AR cube over AR is equals to 27 over 12, and R square is equals to 27 by 12. And R is equals to square root 27 over 12. That is 3 by 2. We are taking only positive because the condition is given in question that terms are positive. So when R is this, we can find A. I'm using the first one. AR is equals to 12. R is 3 by 2 equals to 12. 12 2 times 24. 24 by 3 is 8. A 8 and R 3 by 2. Question 5. 3 by 2 and 8. Try question 6.
Is this supposed to be solved simultaneously?
Yep. Sixth is 13 after the metric term. Sixth and 13th. Yeah. Simultaneously.
I'm sort of confused about this.
Okay, it says the sixth and 13th term are 5 by 2 and 320. So when we're talking about sixth term, it is a raised to power 5 and the sixth term is 5 by 2. On the other hand, 13th term is a raised to power 12, which is equals to 320. Find r and first term and then the 10th term. So we'll work for a and r first. Again, I'm dividing a raised to power 12 divided by a raised to power 5 on the other side, 320 divided by 5 by 2. R raised to power 7 and 320 divided by 2.5 is 128. R raised to power 7 is equals to, I'm checking, 2 power 7 is 128. So 2 raised to power 7. Basically, R is equals to 2. And then we solve for A. I'm using the second equation. A raised to power 12 is equals to 320. A is equals to 320 over 2 raised to power 12. 320 over 2 raised to power 12 is 5 by 64. So A and R done. Now we need the 10th term. Term number 10 is AR raised to power 9. A is 5 by 64. R is 2 raised to power 9. 5 by 64 into 2 power 9 is 40. R, A, and 10th term. Question number 6. 2, 5 by 40 and 40. 5 by 64 and 40. Clear?
Sort of. I understand like the formatting of like the way that we wrote it,
Yep. See,
but
same. 6th term, AR raised to power 5, and that is given. Then the 13th term, AR raised to power 12, and that's again given.
yeah.
So these were two simultaneous equations. We solved them to get R and then A. Once done, we can rewrite them. Like if I would write one step in detail, Tn is equals to AR raised to power n minus 1, where A is 5 by 64. And now we can find any term we want. 5 by 64 into 2 raised to power n minus 1. And that's 40. Clear?
So we got A itself, and then we took out the R value for when we were solving them simultaneously.
Yep. Look at question number 7.
Did you go back to 6?
Yeah, yeah. 6 starts from here.
Oh, so to get the ratio, we just put them on top of each other, so 320 over the 512.
Yes.
Okay, R equals 2, and then we just plugged it back into one of them.
Anyone,
Okay,
you
and
can
then we
plug
got
back.
A. Okay.
I used the second equation. You can use any equation.
Okay.
Okay. Question number 7. The sum of the second and third term in the geometric progression is 30.
Sorry, could I quickly grab my charger?
Yeah, sure.
Okay. Sorry, thank you.
So it says the sum of the second term and third term in the progression is 30. Second and third. So second is AR and third is AR square and the sum is 30. And then it says the second term is 9 less than the first term. So second term is 9 less than the first term. Given that all the terms in the progression are positive, find the first term. Okay. So second plus third is 30 and second is 9 less than the first term. So let's
So we can
try
just
and solve
plug
these.
-9 into the first equation.
Yeah, we can do that. But I just need to make something subject. Like if I just replace this in the first one, a minus 9 plus ar square is equal to 30. There's still two unknowns, a and r.
Okay.
That's why I'm just trying to make one the subject. So rearranging. Now I take A as common. R minus 1 equals minus 9. So A is equals to minus 9 over R minus 1. Rearranging a little more, that is 9 over 1 minus R. Now I'm using this A in the first equation. And the first equation is AR plus AR square is equals to 30. A is 9 over 1 minus R times R plus 9 over 1 minus R times R square is equals to 30. Now there's only one unknown. The numerator is 9R, 1 minus R, 9R square, 1 minus R is equals to 30. 9R square plus 9R by 1 minus R equals 30. Cross multiplying, 9R square plus 9R is equals to 30 minus 30R. Rearranging, 9R square plus 30R minus 30 is equals to 0. Simplifying, 9R square plus 39R minus 30 is equals to 0. I'm using quadratic formula. Minus b plus minus square root b square minus 4ac over 2a minus b plus minus square root b square minus 4ac over 2a minus b plus square root b square minus 4 into a into c over 2a. 2 by 3 and with negative sign is minus 5, and we'll just reject that because it was given all terms are positive. So if r is 2 by 3, a was 9 over 1 minus r. 9 over 1 minus r. So 9 over 1 minus 2 by 3. And 1 minus 2 by 3 is 1 by 3. 9 divided by answer is 27. Question number 7. Find the first term. 27. 27. Clear? So basically, the important thing is that we read the question and write the first equations correct, and then it is just simplification.
Okay.
Okay, try number 8.
Is there any like property that we can use to solve this? Or like any other formula? Because I'm using the AR n minus one and I'm just like trying
Okay.
to equate it to something.
See, this was actually a little simpler than that. Three consecutive terms of geometric progression are given. First is given, second is given, third is given. Find the value of x. So if you're using that, you are actually getting first term, second term, third term in terms of a and r, right? These are already in terms of x. So when you introduce a and r, now you're having three unknowns. One is a, the other is r, third is x. But it says three consecutive terms. So the first term is x, the second term is x plus 6, the third term is x plus 9. Would you agree if I say that r is equals to x plus 6 over x?
Yes.
And what if I write x plus 9 over x plus 6?
Yep.
So both of these are r. Now we can equate them. X plus 6 over x is equals to x plus 9 over x plus 6 and cross multiply. A square plus b square plus 2ab is equals to x square plus 9x. So 12 minus 9 is 3x equals to minus 36 and x is equals to minus 12. And demand was to find x. Question 8 minus 12. So that was actually simpler.
So it's just like that. So we just equate the r's and then
Yeah, because we had some relation in between them. Those were first, second, and third terms, so R could be equated.
okay.
Look at number 9. In the geometric sequence, 1 by 4, 1 by 2, 1, 2, 4. I can pretty much see that R is 2. All terms are being doubled. So which is the first term to exceed 5,000? So basically AR is to power n minus 1. What should n be? So it increase 500,000. So A is 1 by 4 already. R is 2, n minus 1 greater than 500, 1, 2, 3,000. So multiplying with 4 on the other side, that's 520 and 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 zeros. And then we apply log n minus 1 is greater than log of 20, 1, 2, 3, 4, 5 to base 2 using calculator. So this is giving me 20.93. N minus 1 is greater than 20.93. N is greater than 21.93. Therefore, N is equals to 22. Number 9, 22. Try number 10. Is it working?
Yeah, I think I'm solving it.
Okay.
N equals 19.
Number 10 and equals 19 is correct. Okay. Okay, let's touch this as well. An infinite series is a series whose term continues forever. The geometric series A is equals to 2 and R is equals to
Sorry.
1.
So this is infinite geometric series, and that poses one more subunit, right? For a series to be over. And then we're going
Yes.
to do differentiation.
Yeah, we just did the formula, which was like when R is less than 1 and more than minus 1 is A
Differentiation is that?
minus R.
Oh, so this is also part of differentiation, or?
A part of same sequence, geometric
Oh,
series.
okay. So after like infinite and further arithmetic and geometric series, then we're going to do differentiation, vectors, differentiation, and integration, right?
Yes.
Okay.
And this is basically the converging series. Only then we can go up to infinite.
Okay.
We where we just did the example 100, then half 50, then half 25, then half 12.5. So it will ultimately approach to zero.
Okay.
So the geometric series A is 2 and R is 1 by 2. So we just start with 2 and then half of that, half of that, half of that keeps on going. So sum of first term, second term, third term, fourth term. So we have that formula as n is equals to, which was Sn is equals to A into 1 minus R raised to the power n over 1 minus R for the sum of geometric series. This is the formula, and sum up to infinity is A over 1 minus R. So first worked example. The first three terms of geometric progression are 25, 15, and 9. Write down the common ratio. So simply 15 by 25 or 9 by 15. 3 times 3, 5 times, so 3 by 5. We use either. Find the sum to infinity. That is first term divided by 1 minus R. So 25 over 2 by 2 by 5. 25 into 5 is 125 by 2, 62.5. Sum up to infinity, like we add all those terms. And then geometric progression has common ratio of minus 4 by 5. The sum of the first four terms is given. R is given, sum of first four times is given. So we can find A. We just have to substitute the formula that sum of terms is equals to A 1 minus R raised to power n over 1 minus R. Now see, we have R and Sum of first four terms. So we have n. We have r and n, and we have the sum. So the only unknown is a. We substitute the values and compute it. Use calculator and get the value of a, 500. Find the sum to infinity. So sum to infinity is a over 1 minus r, where a is 500, or 1 minus, and r was minus 4 by 5. Then we solve it. 500 over 1 minus minus is plus 4 by 5. I'm getting 2500 by 9. 2500 by 9 is 277.7. Okay. Find the sum to infinity for each of the following geometric series. This is 11.5. Question number 1a. So sum up to infinity is a over 1 minus r. We can see the first term is 3 over 1 minus r is second term divided by first term. So r is 1 by 3. Using calculator, 3 over 1 minus 1 by 3. I'm getting 9 by 2, which is 4.5. 11.5. Question 1. That's 4.5. Try question number 2.
$50?
Sorry,
50?
number 250 is correct. Question number 3. First term of the geometric progression is 300, and the fourth term is this. A is equals to 300, and AR cube is equals to 5 to the 10, 11, 12 minus 12 by 5. Find the common ratio and sum to infinity. So I'm using the same A over here. This is 300 R cube minus 12 by 5 dividing by 300 is minus 12 by 5 into 300. Using calculator, 12 over 5 into 300 simplifies to 1 by 125. R is equals to 1 by 125. Now we take cube root on both sides. R is equals to 1 by 5. Now we have A, we have R. A is there, R is there. Sum to infinity would be A over 1 minus R. So A is 300 over 1 minus 1 over 5. So this is 300 over 1 minus 1 by 5 is 375. Question number 3, sum to infinity is minus 1 by 5. Oh my god, my mistake. Minus 1 by 5. That was minus. This is minus. This is minus. So that will make it plus. So 300 over 1 minus minus plus 1 by 5 is giving 250. Question 3 is 250. Going for question number 5. Write the recurring decimal 0.422 as a sum of geometric progression. Sum of geometric progression. Okay. Two zeros, and then we have 4 and 6. Two zeros keep on increasing. Basically 0.42, when it is recurring, it could be written as 0.42, 42, 42, 42. And because it is repeating after 2 units, that is why we're having difference of 100. These are first two zeros will make it this. Then we have four zeros and then 42. 1, 2, 3, 4. And then again 42. Then there are these first four and then two. So 1, 2, 3, 4, 5, 6, and so on. B part says use your answer to part A to show that this can be written as this. So basically sum to infinity. So A over 1 minus R sum up to infinity is equals to A over 1 minus R, where the first term is 0.42 over 1 minus R is 42 divided by 1, 1, 2, 3, 4, and divided by 0.42. I'm getting R as 1 over 100. 0.42 divided by 1 minus 1 divided by 100 is 14 by 33. Shown. Try question number 6.
Common ratio is -2/3, and for sum of the first three terms is -160/3 or -53.3.
2/3 plus 1. Common ratio is correct, minus 2 by 3. And the second thing is 280 over 3. The first term of geometric progression is minus 120. And the sum to infinity is minus 72. Sum up to infinity is a over 1 minus r. So that's minus 72 is equals to a is minus 120 over 1 minus r. 1 minus r is equals to minus 120 by minus 72. Minus r is equals to 120 by 72 is 5 by 3 minus 1 is 2 by 3 minus r is equals to 2 by 3. So r is equals to minus 2 by 3. First done. Second says the sum of the first three terms. So Sn is equals to a into 1 minus r raised to power n over 1 minus r. So sum of first three terms, a is minus 120 into 1 minus r is minus 2 by 3 raised to power 3 over 1 minus minus 2 by 3. So minus 2 by 3 cubed is minus 8 by 27 into minus 1 plus 1 is 35 by 27 into 120 is 1400 over 9, and in the meanwhile denominator is 1 plus 2 by 3 is 5 by 3. 1400 by 9 divided by 5 by 3 is 280 by 3. 280 by 3, which is 93 whole. 93 into 3 is 279, 1 by 3. Did you get where you got it wrong?
Yeah. So we're supposed to use this formula, right? The Sn equals a 1 minus r to the power of n over 1 minus r. Just like,
Yeah, the other one, a over 1 minus r, is for the sum to infinity.
and then ar n minus 1 is for geometric progressions as well, right?
Yeah, that is just for the term number. Term number is a r raised to power n minus 1. And the one that we just did was for the sum.
Oh, okay. Okay.
Yeah. Do practice these.